As I mentioned upstairs, my name is Brian Reel with CATI, Computer Aided Technology. We don't like to be called CATI. CATI is a better way to say it. Yeah, one of our two senior managers for Field Tech Services. I have the western half of the country. My co-worker has the eastern side. But we're going to go over a presentation we did at last year's SolidWorks World, which was the last SolidWorks World, but now going to be called 3D Experience World. But it was one on hardware performance, something that we get questions on quite a bit. We've done a fair amount of these types of presentations over really about the last 6-7 years. We get equipment from suppliers. Box and NVIDIA have been really good to give us stuff. We've got to give it back. We don't get to keep it. But allows us to test multiple scenarios, all the different, not all, but a lot of the different variables that you might encounter. Hard drives, amount of RAM, video cards, processors, which are a huge part of CAD. So yeah, we presented this, and this was our kind of a theme of the Top Gun theme. So when you think of Top Gun, of course, you're thinking of the need for speed, right? We want faster computers and all that good stuff. You guys know this is coming back for a part 2, I guess, fairly soon. This guy won't be in part 2, obviously, but I think the guy on the left will be, in some fashion. But yeah, so we have the need for speed, and so we were able to test a couple of different box computers, different setups. We chose box because A, they partner with us and they let us have some machines, but most specifically, we get to overclock the processors, and we're allowed to do so. They know how to keep them cool and to keep them running. Dell, Lenovo, HP, they're not quite as friendly in letting us overclock those things because you can break warranties and all that good stuff. So we're a little bit of daredevils. We forget the rules. We're going to overclock these things. So this is one machine we tested. This is an i7. Again, he's a little over a year old, the data, but it still holds true. Some of the numbers might change, but the common theme seems to be there with each year that we do this. What we tested, though, is the i7, a 6-core, 4 gigahertz out of the box. We overclocked to 5. That's as fast as we went, was 5 gigahertz. But we also had 32 gigs of RAM in that machine, a solid state, as well as the new M2, which is kind of a chip-based hard drive. So we have those as well that we tested. And just a very standard run-of-the-mill P2000, nothing super fancy graphics card. A pretty average card that I think most users could work with. So that was what we tested with that first machine. And then we had a second machine, which we're going to call this one Goose. But this was an i9, and we didn't realize that i9 and i7s aren't the same. There's a little bit of difference there. It's not apples to apples. But we don't really know how many customers are using i9s yet when this test was first made. So we chose to, even though this is a really cool machine, a lot of RAM, and again, not such a great or super powerful graphics card, but still the 2000. So we decided to unretire another i7 that we had. We didn't like Iceman. Nobody likes Iceman, right? So we brought in Slider instead. So we've got Maverick and Slider as our two main test boxes. But again, looking at a 4.2 overclocked to 4.8. Again, not quite the same as 5, but we're still on the same architecture of processor, and that was kind of our goal. A little bit more RAM, but also a little bit lesser of a graphics card. So we've got a lot of different variables here, at least out of the box. What you'll notice, though, is we also tested many different video cards. So not just these two. We ended up testing, I think, like 8 of them total, 8 different cards. So, again, a little shout out to NVIDIA. We're not a partner. We don't get any money or anything like that. But NVIDIA seems to be a great partner with SolidWorks. Not to say you can't use other brands of cards, but we pretty much standardized with NVIDIA either on our training machines or our demo machines, internal and external. And we find that a lot of SolidWorks users use NVIDIA cards. So that's why we thought it was an okay choice to pick from that. Of that, we have these models of cards. So we've got the K2200s, the M2, the M4, the P1245, and also the P6000, which is a pricey card, about $4,000 at the time for that particular card. But what we also discovered is that roughly of the K22, the M2, and the M4, the whole, that is about what 60% of SolidWorks users are using. The top three, the K22, the M2, and the M4. Those are what we found that, again, based on SolidWorks polls that they do, ones that we polled our customers with, that's what most people are using. So we definitely wanted to include those so you can kind of see how you're at now. And then once we get all that testing done, NVIDIA throws another one out there, said, hey, test this new RTX 4000. It's like, oh, great, now we got to rerun all of our tests on this new card. And they were literally doing that like 3 days before SolidWorks World. They were able to finalize that last test. But they wanted to include it, and I'm glad they did. You'll see why once we get to the results side. So the newest card was the RTX 4000. I think they have a 1, 2, and a 4, 1, 2, 3, and a 4 now. So they've got multiple models. But at the time, the 4000 was the newest one. So this is what we tested. We've got the CPU, again, from 2.6 all the way to 5, roughly doing about a half a gigahertz jump each time. We're testing 2 different storage devices, hard drives. We're testing all of those video cards, even a K620, which is a much smaller card, more entry level. We've got 3 different levels of RAM, 16, 32, and 64. We have all the different SolidWorks settings that you can just change without buying anything, just simply changing these settings internal to SolidWorks and seeing how that information affects your file performance. And then last but not least, which I'll talk about in just a second, are the actual models that we tested, the CAD models inside of this test. So we actually had 6 different models, well, 3 different designs, but testing them 3 different ways for one and 2 different ways for the second one. For our benchmark, you guys know within SolidWorks RX there is a benchmarking tab or benchmarking tool, so you can actually do your own benchmark with just using SolidWorks functionality. What we chose to do though is we have another division within CATI called Inflow Technology, and it's basically our group that deals with nothing but PDM, custom programming, weird geek stuff beyond what I do. And we have a programmer, Bob Hansen. He's written tons of custom programs for SolidWorks. We said, Bob, can you create a macro or an API that will actually open the file, do something, save the file, close it, open the next one, and just a series of tests. So we do things like open, save, closes, pack and go, rebuilds, complete, and normal rebuilds, so Control B versus Control R. You've got feature creations, assembly creations, just trying to do daily work. The one thing we didn't do, just because we ran out of time, was how drawing performance. So this is basically parts and assemblies. That's really all we're testing with the architecture that we have. Drawings have their own unique challenges. With 2020 just being released, there's some new functionality in drawings that might be worthwhile testing. But we usually do this every 2 years, so I don't know if we're going to get it done this year or not. It's a bit of an undertaking to get all this stuff done. But again, thanks to Bob to create that. 2 or 3 years ago, we did this test, and Desktop Engineering actually produced a white paper for us that was distributed all across the country. So not sure that we're any better than anybody else, but we've just said we'll test it. So we're able to put our results out through that. The graphics test I was talking about inside the benchmark tool. So if you open up SolidWorks RX, go all the way to the right, you'll see the benchmark tab. If you click that, it runs a series of models through your hardware, and you can see how your hardware compares to the other people that have done that test. It doesn't do a very extensive benchmarking, not like the one we're doing, but it doesn't do too bad. You do get some mouse recording emulated of the playback of your model and what it's doing through that. There is a frame rate monitoring software. The reason why we included that is we wanted to see how many frame rates the video cards are handling. If you're using video game cards, you're expecting fast throughput, right? I'm cranking out the graphics. I don't care how accurate they are, I'm just cranking them out. In SolidWorks and CAD, you're wanting accurate graphics. I don't want to see gaps in walls. I want it to be watertight. So the frame rate is dialed down extensively, but allows that detail to show through. So we want to see what type of frame rate we're actually getting. Again, there is an option. There's a little registry hack. Don't look at this if you don't want to go hack your registry. Any IT professionals in the room? Good, because I'm not showing it to them. But that's how you would go change that registry if you wanted SolidWorks to show you and display, kind of like we see here at the bottom here, this display, that is what's going to be shown on your SolidWorks window next time you open the program. But it's that little registry hack, and you can actually record your frames per second just internal to the software. I think the setting is 0 for off. You change it to 1, it comes on, right? So we decided we want something a little more extensive. You have something called FPS monitor. We had another one called Fraps, and we decided to go with FPS monitor. It was the low price of $9.99 to buy this application, but it allowed us to show what I'm showing here. So that color detail, the frame rate, not only for the GPU, but also the CPU. And if you have multi-core machines, you're going to see multiple cores showing that information as well. It's really nothing earth-shattering here. It's just giving us a number that we can report in our findings. That's really all it's doing. The higher the number, the faster things are being displayed, right? The more throughput you have. Okay. So that's what the FPS monitor does. What did we test inside of SolidWorks that could affect graphics performance, hardware as well as software? So your graphics card, obviously, the right driver. My goodness, guys, if you don't have the right driver installed, you might as well have put, diesel inside of an unleaded gas tank. You're just not going to get the performance that you want. So the biggest problem is having Windows 10 wanting to put the new driver on there for you all the time. It might not be the one SolidWorks has tested or approved. So that's a constant struggle to keep checking that video driver. What are consistencies that you would see? I go to click a sketch dimension, and I double click it. It takes 3 seconds for the modify box to pop up. That delay, that lag, that's all graphics card that's hitting that. So things like that, watch for. That's usually a telltale sign you've got either the wrong driver or not the one that's approved, basically, right? CPU performance, the amount of RAM that you have, assembly size, of course, how complex the geometry is, level of detail. Level of detail right here is what we're showing over here. That little slider box, I'll give you just a quick little horror story. That is a file-specific value, so it's in your document properties. Had a company that had imported data, it was like an imported Caterpillar engine for this truck that they were building. And, of course, it comes in with several hundreds, if not thousands, of components, right? Well, they had an intern that built a template file that was utilized or pointed to when SolidWorks was converting this step into SolidWorks models. At the template, they had that slider almost all the way to the red, like you see here. What that does is it way over adds tessellation data, makes circles look really smooth, and it just increases the file size. That data set was almost a gig. They're complaining, SolidWorks is a piece of junk, I'm throwing it away, all this. I'm like, let's visit, right? So we went out, and first thing I checked, I don't know why, I got lucky. I'm not going to say anything else, but I checked, and the setting was way over the red. I'm like, come on, this can't be right. And luckily, inside an assembly file, if you open that top-level assembly, and it took about 45 minutes for it to open, but when it did, there's a setting that says apply this to all reference documents. So I opened the top-level assembly, slide it back to about 30%, which is where it needs to stay, right, for day-to-day work, saved it, and we went from 900 and some odd meg to 275 or something like that. I mean, dropped it by almost 75%. Needless to say, they're very happy and everything's fine. Simple answer is change your template, obviously, but it's a good setting to check. It is nice if you want to do a rendering, slide it up high, make it look good, slide it down before you save the file stuff, right? So be careful with that level of detail. We had a customer file set that we're using for benchmarking. They suffered that same little extra step right there. They had it way too high. I've had models that if you slide it into the red, the model actually becomes corrupt. It will not open. So be careful with that too. New option in 2019, performance pipeline. Has anybody gone to 19 yet? Some of you? So it was a beta setting in 2020. It's now fully engaged. It's no longer beta. But what performance pipeline does is finally in the year 2019, we are using the graphics processor chip to control graphics inside of SolidWorks. Brilliant, right? So that was a new function, and it really worked with larger data sets, not so noticeable with smaller, but larger, much improved. So this is our first example. It's one of our customers. They're based in Oregon. We're on the West Coast. This is a fairly small assembly, about 1,500 components. There are some multi-body parts, so we have 1,590 bodies. But this is one of those designs that suffered from that high level of detail. So we ran it a three different ways. Yeah, good average size top level assembly, nothing crazy, but something to start with. For a second, we chose to borrow the telescope, the Canadian, Hawaiian, France, Hawaii telescope. It was our What's New for 2018, I believe, or maybe 2019. I can't remember which one that was from. But this is a much larger assembly, so we're up to about 7,500 components. Again, a lot of welded structure, so we have a lot of multi-bodies. So 22,000 bodies, that's a pretty good-sized assembly. You know, we're looking at, when it's finished, this entire design is probably going to be about 10,000 components. So that's not the full data set we had, but that's what we could work with. So kind of have a small, now a little bit bigger assembly to look at. And then our final one was actually a design again from one of our customers, Racing Railroad. They designed this piece of equipment that actually attaches clips to the railroad, or to the ties for the railroad. And so this was a pretty large machine. Again, a little over 10,000 components, almost 15,000 bodies with some sheet metal and weldments and things like that. But pretty good size. And we're like, well, that's good. That's 3. We really need 4. So how do we make 4 components, 4 tests? We just double it. We put 2 of them in one big assembly. So we've got a super huge now, 21,000 almost components. That's our beast that we wanted to tackle with the benchmarking test on. Anybody have a large top-level assembly larger than 21,000 components in here? You do. What design? Okay. Okay. So all the components on the PC board? Okay. Yeah. Wow. Okay. So might be not quite as big as this, but or bigger, I should say, than what we have here. But this was our top level one that we wanted to try. Is it? Ah, gotcha. Okay. So there's some big designs out there, no doubt about it. So we have about 800 custom benchmark tests. We tested 9 different video cards. We did the SolidWorks benchmark, plus we did our own custom benchmark. So a lot of data, a lot of things we're going to run through. We ended up coming up with over 141,000 data points. If you ever get scared at night and have a hard time sleeping, that's what it looks like. If you want to read through that Excel file, you're more than happy. One of our guys doing the testing, he had autosave turned on or off. I can't remember which one. And he was doing something and looked like the entire screen just wiped itself clear. And he's like, oh, what did I do? And he eventually figured out what it was. But I had a little panic moment there at the beginning, looking at that. But yeah, maybe glad autosave was turned on and that was able to keep it. I don't know. But a lot of data that we're trying to look at, and we're going to hopefully compile all that into the next several slides here. So that's a little bit about the test itself. What about the hardware? So we have RAM, which is obviously a very important function of SolidWorks. How much is enough? What's the critical point? We want to have enough so we're not doing swaps to the hard drive and things like that. 64-bit OSs have obviously enhanced the amount of RAM that we can have. So that's been a big push over the last several years. But without enough RAM, things like machine running slower. We've seen stability. Files become corrupt because there's not enough RAM, and they won't open correctly. It's rare, but that does still happen. Sometimes memory errors, the crashes you see, are because of a limit of the amount of memory that's there. It's not SolidWorks just throwing their hands up and saying I'm done. There's really a problem, and that's why it's not able to complete whatever that task was. So based on our testing with RAM, this has held true the last 3 or 4 years now. SolidWorks, just core SolidWorks design, will not use anything more than about 14 or 15 gigs of RAM. SolidWorks core functionality. Yep. 14 to 15 gigs of RAM. Now, if you're doing things like some of the newer, well, not even the newer features, simulation, renderings, the more you have, the more it's going to use. Of using more RAM, or? Nothing else is running, just SolidWorks? Interesting. Interesting. So that was with the D feature command. Food for thought. I'll have to take a look at that. But yeah, so basically we're at that 1415. Now, if you have Windows running, obviously you do, but Outlook, maybe a couple other 3 programs, they're going to take advantage of the more RAM that you have, right? So not saying you just need a 16 gig system. 32 is kind of the sweet spot that we see a lot of people getting today. But SolidWorks itself is not going to really use much beyond that. Processor. Obviously, that's a big part of the equation as well. The speed on the processor is the important part. Watch out for marketing information where they say turbo processor, or turbo something or other. All that means is we're going to go really fast for a short amount of time. You can't maintain that speed. A lot of laptops like to say that. Well, guess what? When you increase your speed, you increase your heat. These little fans can't keep up. They're going to shut down and slow everything off. So it's not a full-blown true speed. Get the true CPU specs either from Intel or AMD if you're buying that processor, but watch out for the marketing fluff. Don't just buy into that. Look at the true speed. That's what you want to factor in. So, based on strictly processor, what we've discovered is the overall time is doing open, close, and rebuild. So the slower processor, 2.6, takes almost 80 seconds to do that task. The 5 gigahertz, we can do that in roughly half that time. So for every increase in speed, hardware or CPU speed, you're getting a decrease in time. It's always improving. We never saw it bottom out. So the fastest processor you can get, the faster it's going to run. Again, SolidWorks is still basically single core. There are some newer features that can handle a dual core or a second core, multi-threaded to some degree, but the entire program itself is so many million lines of code that it would be a true rewrite to take advantage of all of that. So this is just considering what SolidWorks is using out of the box, basically. Yeah. So again, kind of looking at that that difference. The difference here is we're not using large assembly mode. That's what LAM stands for. So large assembly mode, we're loading everything, all the display settings. We're not stripping anything away. So again, same rule applies. We're roughly 11% faster for each half gigahertz increase. Hard drives. Now in the past, we thought about this guy. Hopefully you don't have those anymore. Does anybody still have spinner drives? Probably not. Hopefully not. If not, leave that company and go somewhere else. No, I didn't say that out loud. But so we tested solid state drives because that's obviously the most common usage right now. The solid state has hung on pretty well. The size of the drives have gotten bigger and less expensive over time as well. But we didn't test that this year because what's the point of testing spinners? Nobody should have them anyway. So we tested the solid state and the new M2 non-volatile memory, which is, like I said, almost like a card, just a chip that plugs in, and your data is stored on that. My new laptop has a terabyte of the M2 solid state version. And so we thought, well, that's a good comparison because this obviously should outperform immensely. If you look at the chart, you know, your solid state, you're reading and writing 122 and 56. Well, we're at 3600 and 2300. I mean, it's a massive increase in performance, right? On paper, yes. But once we ran the data, the two drives performed almost identical. And what we found, first we're like, okay, we did something wrong. Who didn't, who's not putting in the data correctly, right? So they called SolidWorks development. We did. And one of the developers got on the phone and were like, hey, we're running this test, and these two drives are within, plus or minus, less than 2%. And they're like, oh, good, that's the same thing we found. We're glad you guys found it as well. I'm like, well, that's not exactly what we want to hear, but okay. What we're basically seeing, and I guess the nice way to visually show that, is hard drive is not the bottleneck. Your hard drive should not control performance in one shape or form if you have either a solid state or that new MVE, the non-volatile memory. So what we're seeing is it's almost like you take your CAD data as a penny and drop it through a 10-inch pipe. It's not going to hit a wall. It's just going to fall all the way through, right? Totally fine. That's what we're seeing with these two types of hard drives. So just food for thought, again, based on what we saw with the models that we tested. Okay. Graphics processor. So again, as I said, with 19, we're able to take advantage of the graphics processor now. There are still some things, some intangibles, the look and feel that I think you get. If you're rotating a model, do you like for it to spin and get clunky so it reduces level of detail, or do you want to see all that detail? Those are things that getting a more expensive card might bring to the table. It's not going to really outperform any better. It's just that response or the feel or what you're expecting to see with that card. And those are things that are hard to really put a price tag on or a comfort level, whatever you're wanting to see. But that's part of what that frame per second does for you. So if you think of frame per second, this is one of our models we did. This is like a First Robotics model or something like that. And we chose that to be our rendering project, to test the rendering functionality, because we're going to really hit the cards with that. So this is visualized with the CAD model. Looks pretty real, right? Not too bad. So we tested the cards, these 5 cards here, using SolidWorks Visualize. The K2200 is the oldest card, so we're going to see slower performance with that. The M4000, the P4000, and the 6000, again, it's the same type of architecture, a little bit different between the M and the Ps, but what we're seeing is it's the more expensive cards you get, the faster it performs. It's kind of a typical scenario there. And then somebody decided to throw this RTX 4000 into the box, and that completely threw that on its head, because what we're seeing is this card is $4,000, this card's $1,000. And look how close. It's even $800 now. So look how close performance you're getting, and you've saved, 20 or 75% of your price right there. Oh, price-wise? Okay. Okay. Yeah. It's newer architecture. The RTX is ray tracing something. I forget what the X stands for, but it's just a better way of handling the graphics. And then doing the performance pipeline, that's that new setting in 2019 I was talking about that was beta. We turned that off, and we did the different display styles. So shaded with edge, shaded, hidden removed, hidden lines visible, and wireframe. And again, if you're looking at the P4000, the most expensive card, actually the P, I think P should be more expensive than the M4000. But we're fairly close, on all 3 of those with performance-wise. Shaded with edges is still the I think the display of choice that most people like. Shaded used to always be the fastest display model, but shaded with edges has caught up or is pretty close to it. And again, that was just communication between SolidWorks and NVIDIA. We find that most users want to see shaded with edges. What can you do to make that perform better? And that's kind of what we're seeing. So this is the shaded still performs best because it's frame rate. So the 2000 actually can do a little bit higher frame rate with that. And then we did the same thing, but we turned on the performance pipeline. So the numbers should actually increase. We're getting more frame rate per second with that. But again, not a whole lot of difference between just simply either using that performance or using it off. This is all using that very small model. That first one with like 1,500 components, I think roughly is what it was. That's what we tested with this portion. And then I think we did the same test again. Just some different cards. So we put the RTX 4000, and look at the frame rate. It just blew through the roof on what it can handle. And that's because that RTX card, the graphics processor, is handling more of that data than what we were. So this is the racing. This is the one that's putting the clips on the railroad. So a little bit larger performance with that as well. So those are things you could buy. These are things you don't have to spend a dollar on. So settings inside of SolidWorks, right? These are the four that we think have the most play with performance with your hardware. So large assembly mode, verification on rebuild, kind of a weird setting. Not many people understand what that does. Level of detail slider, I already harped on that one for a little bit, but that's something to think about. And then image quality as well as level of detail. Those two kind of play together. I'll talk about those as well. So the first one here, called verification on rebuild, is a setting that when it's turned on, it's a system setting, so it's per machine. When that is turned on, what SolidWorks will do is it'll check the feature and the surface that that feature is on, but it also checks all connecting faces to that feature as well. Even if they don't connect, it's basically looking at every face. All right? So it's a much more extensive check. If that check is turned off, we're ignoring and only looking at the ones that were affected by that edit or change or creation, whatever happened. So when you rebuild the model, it's only looking at the face that had that particular feature hole cut or whatever on it. That's all it's looking at. So it doesn't do quite as extensive, therefore it's less performance hit. It's going to run a little faster. Turning it on is a good way to verify your model is working correctly. You don't have rebuild or gaps or other errors that maybe weren't reported. So turning it on will report that, but it is a little bit more of an intensive process. So it's something that I think you could probably go on and off based on everyday designs. Just turn it on, rebuild, everything looks good, turn it back off. You can probably create a macro. Just turns it on and off. Easy to do, right? So that's something to consider. It doesn't improve anything. It just does better checking of how that model is performing, how it's working, how the geometry is reacting to itself. Obviously, when you turn it on, things go slower. When you turn verification off and rebuild, it's going to rebuild quicker. So this is time to rebuild versus having it turned off. So a little bit of difference there. Not quite 50%, but for 30% or a minute 30 slower, not going to do it every time you rebuild. You just need to do it kind of at the end of the design, right? Before you're ready to save it and move on. Level of detail is more specific to your video card. So what you're doing is you're setting a target range for, again, this is a system setting, of where you want SolidWorks to perform when I'm doing rotate, spin, zooms, all that good stuff, right? So if my card can handle more options, then I can turn level of detail off completely, and it's just going to rotate as best it can. If I turn level of detail on and I make it less, then my part becomes kind of blocky so that it can keep up with the rotational speed that I'm applying or that I'm putting on there. So that is more of a target rate, but again, SolidWorks will do whatever it can to get to that range. All the way to the right is the fastest possible, but the less amount of detail is usually shown. Back to the left, you're going to have much more detail and a slower rotation because it's making sure every graphic image looks correct, or perfect almost, right? Correct. Yep. And you have to point that out. If you have it completely turned off, then you always get the block graphics. So it's not even trying to enhance. It's just going to simplify and make everything blocky. All the way to the left, you've turned it off completely. Okay. And again, I've got this as a PDF, so I can share with you guys. Image quality, we've already talked about this. I don't want to go into so much detail again, but again, this is a part level specific setting, so be aware of that. It can make or break a lot of your designs. That's a good happy spot right where it is. Try to keep it at that location or somewhere close to it. Definitely don't go into the red if you can avoid it. Simple report here, level of detail. If we had it at 95%, 242 meg, we set it to 20%, we dropped to 157. So this was that first design from Oregon. They had level of detail cranked up high. We're like, what are you guys doing to us? So we slid it down, and we're able to increase their performance just with that simple setting. I like my example better because I went from a gig to like 250 meg, but that's still a pretty good savings there. And then obviously large assembly mode is something we've had for a number of years. SolidWorks keeps improving that. It's a setting you can turn on or turn off. Again, system setting. It defaults to 500 components. So if I open an assembly with 501 components in it, it's going to automatically turn on whatever I'm doing in large assembly mode. So these are the settings you can pick from. Don't save auto recover. Don't rebuild when you're switching windows. Hide all planes. Make graphics simpler. These are all the things we're doing to try to make your lesser machine perform better with a larger data set. Right? If you have a NASA machine, you don't have to worry about these settings. Everything's going to be fine. But we all can't afford NASA computers, right? So that's what these settings do to try to help get a more range of life out of that machine before you retire and go to the next one. The target frame rate is also set to 14 when you turn on large assembly mode, so your frames per second is going to automatically go to 14, more towards the lesser of detail size. So again, just doing a couple of testing with our cards. Large assembly mode on or off. Obviously, when it's on, things should perform quicker, as we're seeing. This is more with larger data sets. Notice the MD01, 2, and 3. That was that small assembly. We're not seeing much difference, whether it's on or off. Not a whole lot of difference there, right? But getting to that double assembly machine or double assembly data set, we almost cut that in half just by turning on large assembly mode. So, something to consider. Not saying you want to leave it on all the time, but definitely something to consider there. So what did we learn? We learned a lot of good stuff. Performance pipeline is really cool. Should be even better in 2020. 2019 was still beta, had a little quirkies going on, but 2020 should be a better result from that. Graphics drivers, yes, check, double check, triple check. Make sure you've got the right one loaded. You guys know you can test that in SolidWorks RX. When you launch SolidWorks RX, there's a diagnosis tab. Immediately runs through and tells you if you have the right driver. It does require an internet connection. It's pinging the SolidWorks server to make sure your hardware matches the driver that they see. So it takes a little bit of time, but it's a nice way to check that. There's always going to be a bottleneck somewhere, whether it's network speed, right, working across a server versus working local. You can have the fastest hard drive in the world. If you're across the network, you threw it all out the window just about, right? So getting things copied local, PDM, things like that can help to reduce bottlenecks of speeds. And this was what we found. Your mileage might vary. You might come up with different results, but this is kind of what we saw from our testing. Always get as much CPU as you can afford. That's where I would spend my money. Hard drives, again, either one of those two are going to be identical almost, so no big deal there. RTX is new. It's still coming out. So far it looks great. If you can find an RTX video card, it might be worth it. They're putting them in laptops now too, so you have access to those there. We did not get those before we got our new machines, unfortunately. So I don't have an RTX card. But performance pipeline, again, that was that setting in SolidWorks. It's for the K, the Kepler, the M Maxwell, P is the Pascal, and Volta. I haven't seen the Volta cards yet. I don't know what that's relating to. But something to keep in mind. And then obviously verification and rebuild, large assembly mode, and check your template settings. Don't fall into the trap that they did. And guys, that's all I have. So hopefully that was a good amount of information. Hopefully we'll do a test again as we keep growing with hardware, but that should get you by for a few years, I would hope. Thank you.